Later, on a separate video, we are going to solve this homogeneous equation. But first, let us of course establish that this is really a homogeneous equation. In order to do that, let us try to identify the functions m of x of y plus n of x of y dy equal to 0. Our m of xy here is a function written beside our dx. That's actually y squared plus yx. Now, for our n of xy, take note that it should be the function multiplied to dy. It's not just x squared, take note of this, but it should be negative x squared, as our general form or standard form in this case is on addition. So we have here minus x squared. Please take note of that, because it might not be so much needed here, or it might be negligible, but as we solve it later on a separate video as mentioned, this is very important. So let's continue. The goal here is to come up with m of tx ty and n of tx ty. That would mean we are going to substitute tx to x and ty to y for each of the given functions. And let us try to rewrite it in this form, times the original m of xy. If we could factor out t to raise to a certain alpha exponent times the original m at the same time to our n here, then we are one step closer in determining whether this given equation is homogeneous or not. Because the next thing here is to make sure that alpha on both expressions are of the same value. So let's start with m of tx and ty. So again, for this, we are going to substitute tx to x and ty to y. So the y squared will become ty squared plus ty times tx. Okay? This is t squared y squared plus here, simply multiply. You have t squared yx. As we factor t squared, you will have here y squared plus yx, which is our original m of xy. So you have t squared m of xy. Transform into this form here. Thus, we can say now that our alpha is 2, as this is the exponent of our t. Now, let's see if we still have the same alpha as we look into n of tx ty. This would mean you have minus, instead of x squared, you have tx, and then you square that. Okay, so as laws of exponent tell us, again, take note here, we are not squaring the negative sign, we are only squaring the tx as we substitute it for the original x. You have t squared x squared. Move out here t squared, you have minus x squared, sorry. And this is our original n of xy. So that's n of xy. So similarly, our alpha here is 2. Since both alphas are of the same value, we can now simply say that our given equation is a homogeneous equation. And with that, we are now good to continue on a separate video in solving this given homogeneous equation. So please watch out for that video soon. Thank you very much for watching.